Okay, this is a situation we've seen before. In fact, we even set up the probability table for it before. But what we're going to do here is come in with a different approach. We're just going to check out the formulas we've been talking about. So the first one, we've got to find the probability that a student studies maths given that he or she studies English. Now the formula for conditional probability, okay, if I use M to mean maths, then the probability of maths given that we study English, the formula for the probability of M given E is the probability of M and E, so that the top's always easy, divided by the probability. To remember which probability you divide by, it's always the probability that comes after the line. So it's divided by the probability of studying English. Okay, but these probabilities I've effectively got. The probability of studying M and E, let's set them up. Probability of M and E, well, I've got 10 students studying both subjects out of 50, so that's 10 over 50. And the probability of, on the bottom, the probability of studying English is just 25 students out of 50, so it's 25 50ths. So my formula says the probability of M and E over the probability of E is top number is going to be 10 50ths, bottom number is going to be 25 50ths, which you can do in your calculator if you really like. But because they're 50ths on the top and 50ths on the bottom, what I can do is multiply top and bottom of the fraction by 50. Effectively, the division by 50 cancels, ending up with 10 over 25, which actually simplifies to 2/5 or even 0.4. So that's my answer for the conditional probability. It's 0.4. Okay, and part B, so that was part A. Part B says determine whether studying English is independent of studying maths. Well, let's use the test that you've got higher up the page. Events are independent when the probability of A and B is the probability of A times the probability of B, because I've got most of these things already. Okay, I've got the probability of M and E is 10 over 50. I've got the probability of M, well I haven't yet, but it's 30 over 50. And the probability of E is 25 over 50. So I can see what happens when I do P of M times P of E. Well, that's 0.6 times 0.5. These things expressed as decimals, which when you do it is 0.3. Okay, and the probability of M and E is 10 over 50, which is 0.2. So the probability of M and E, which is 0.2, is not the same as the probability of M times the probability of E, because this is 0.3. Therefore, they are not independent. So I've gone out of my way there I've gone out of my way there to show you how the formulas worked. Actually, there's another more straightforward way of doing it. If they didn't affect each other, then the probability of studying maths should be unaffected by whether you studied English. So this 0.4 should be the same as the probability of studying maths. But actually, the probability of studying maths is this, which is 0.6, not 0.4. So I can see from that mismatch between the probability of maths given English and just a straightforward probability of being maths. These two numbers being different is enough to show they're not independent. But to be honest, remembering this rule here and always applying it, you won't go far wrong. So that's why I did it that way. Okay, the other method is to use the probability table. Here's the two-way table from a couple of pages further on, but remember now I want to work out the probability of studying maths given that I study English, and I want to check for independence. So for the first one, if I'm studying English, it means I only need to consider this top row. The only place where people study English is along the top of the table. So that means I'm not thinking about all 50 students, I'm thinking just about 25 students. So I have 25 on the bottom of my fraction. Okay, so I forget all about anything apart from the top row. So I'm just looking at those top three numbers. How many of the 25 students study maths? Well, 10 of them do. So my chance of studying maths, if I already know I'm one of these English students, the chance that I study maths is 10 chances out of 25. So I have 10 on the top. So when you're doing conditional probabilities from a table, that's when the bottom number stops being the total number of things in the table, in this case 50, because we're just looking at one part of the table. In this case, it's just the top row. Okay, so that's the answer to the part A of the question. When I do B, I'm going to do this similarly. I'm going to test whether the probability of, well, I want independence. So for independence, the probability of M and E should be the same as the probability of M times the probability of E. Okay, well, this is very much similar to what we saw before. So the probability of studying both, here are the students that study both. 10 of them out of the total is 50, not a conditional probability this time, so 10 over 50 is correct, all right, which is 0.2. And what's the probability of M times the probability of E? Well, the probability of studying maths is 30 out of 50. So this is 0.6. 30 out of 50 is 0.6. Probability of studying English is 25 out of 50, which is 0.5, which as we saw earlier is 0.3. 0.2 does not equal 0.3. Therefore, they are not independent. So once again, I set it out slightly differently. Once again, I very clearly worked out probability of M and E, and the probability of M times the probability of E, got these two answers and stated they're not the same, and then drawn my conclusion. That's what you have to do to show things are or are not independent.